I think I can start introducing the first speaker of this session, which is Sergiy Gogolenko from the High Performance Computing Center in Stuttgart. And he's gonna talk about the challenges and solution of global challenges in high performance computing. So looking forward to his talk.
Hello everyone, in this talk I will tell you about Hidalgo project, or more precisely about the technologies we use in this project to accurately simulate global challenges on data centers infrastructure via coupling of models and data sources. This is an introductory talk in a series of talks about Hidalgo in this session. One of the key goals of our project is an evidence-based policy making for global challenges via accurate simulation of them. Accurate digital twinning of the global challenges leads to computationally expensive coupled simulations. These simulations bring together not only different models for social and physical phenomena, often multiscale by design, but also various sources of massive static and streaming datasets. In order to deal with computational complexity of the simulations, we use resources of HPC centers. As a result, on the one hand, we have high-performance computing and data centers, which typically operate on static data, on efficient, parallel and distributed file systems, have strict security restrictions for external data sources, and offer different proprietary software, models, and data. On the other hand, we have global challenges which combine computationally expensive models and are greedy to data from external data sources. It leads to the following problems: how to involve external data sources into the simulations, static simulations. And the second problem is how to couple across data centers. In order to establish the baseline for a generalized solution, in our project we rely on twinning of 3 representative global challenges. Let's go quickly through them. In the migration use case, we tried to simulate and analyze data about movement of refugees from conflict regions. We operate with data about weather and climate, UN Refugee Agency data, food security and telecommunication data. We use micro and macro scale models based on modeling and simulation with agents, weather of climate forecasts, geoinformation systems. Most of the codes is implemented in C++ and Python. Our software was used to analyze conflicts in Burundi, Central African Republic, South Sudan, as well as Mali. In the urban air pollution use case, we design a digital twin for the spread of vehicular air pollution in the cities. We operate with data about weather and climate, streaming data from sensors, data about geometry of the city extracted from open and closed sources. We use agent-based modeling and simulation for traffic, for simulating traffic, computational fluid dynamics, air quality in the cities of Győr, Stuttgart, Milwaukee. In social network analysis use case, we analyze spread of messages in social networks. We operate with streaming data from Twitter, telecommunication data, data about social networks from open datasets. We use agent-based modeling and simulation for simulating spread of messages, numerical linear algebra and network analytics tools for analysis of the results. Recently, we used our software to analyze tweets about COVID-19. The global challenge discussed above were used to construct a generalized workflow for simulation scenarios. You can see it in this figure. The data source phase denotes the starting point into the workflow, including local files as well as external APIs. Then follows data extraction, data synthesis, and data processing phases. Afterwards, we have model generation phase, and only then simulation phase take place. After simulation phase, we have analytics phase, which in case of successful validation and verification of results allows to report policies. In Hidalgo, this workflow is implemented with the following architecture. In order to establish a computational infrastructure, we exploit resources of the 3 leading European high-performance computing centers. High-Performance Computing Center, Stuttgart, Poznan Supercomputing and Networking Center, as well as European Center for Medium-Range Weather Forecasts. HLRS and PSNC provide resources for general-purpose applications, while ECMWF provides access to the forecast models outputs, weather forecast models outputs. The overall execution is orchestrated and monitored by Cloudify. Streaming data is integrated with Apache Kafka. CCAN serves as a data management system and data catalog. Out of the box, Cloudify supports clouds and basic and acyclic coupling mechanisms. It is based on Oasis Tosca standard and has an attractive web GUI. Finally, Cloudify is extensible via plugins. To extend the functionality of Cloudify required by our project, we developed a plugin called Croupier. This plugin already supports HPC and HPDA workload managers and data catalogs. The work on Torque and Slurm is in release, while the work on Mesos and CCAN support is in a beta version for testing. Additionally, we started to work on extending Croupier with cyclic coupling mechanisms. Locally simulated parts of models for our representative global challenges rely on a number of acyclic and cyclic couplings. Some of them are presented on this slide. In order to establish such couplings, we use tools like FabSim and Muscle. CCAN is used for linking external static data sources. It provides consistency in harvesting the data and post-processing and pre-processing of the data, adequate level of security. Finally, it is extensible via plugins, which is very helpful for our project again. It allows to deliver data with files, links to external sources, and profiled harvesters. The streaming data is integrated in our project via Apache Kafka. We use the following sources of streaming data: Twitter data, camera-based traffic data, and monitor-based data about air pollutions. In our cross-data-centric couplings, the role of specialized data center is assigned to ECMWF, who provides weather and climate data and forecasts. The coupling is implemented in 2 steps. The first one is static coupling, where we try to couple with historical data about weather and climate, useful for model calibration and verification purposes. And the second step, we do dynamic coupling, via coupling with weather forecast data via a RESTful API. The architecture of coupling implementation is in the background of the slide. The client side is implemented with the free and open source software piece called Polytope. Cross-data centric coupling is probably one of the most interesting and innovative bits in our coupling activities. For further details, I refer you to the talk of Milana Vučković later on in this session. The future work in the project assumes the following steps. We intend to develop mechanisms for moving and handling large simulation results, improve mechanisms for cyclic coupling across data centers, implement strong coupling in the case studies, evaluate performance for the proposed solutions. Last but not least, I would like to mention that this is a collaborative project which involves 11 partners from different European countries. Some of the key partners and contributors to this talk are presented on this slide. Thank you for your listening to this talk. Thank you for your attention. And please stay for later discussions in this session.
Thank you. Thank you so much, Sergey. So I think we can open up to question. If there is no question from the audience, maybe I will come up with a couple. Sergey, can you hear me?
Yeah, thank you,
Yeah,
Stefano.
hello. Very nice talk, by the way. Very impressive work, very complete. I like it a lot. So let me ask you a couple of questions. So how can you indeed implement a stronger coupling mechanism for your architecture?
You mean how do we intend to? Well, okay, in our activities, we assume a little bit to invest our time into implementation of strong coupling within Croupier plugin, the plugin for Cloudify. In this plugin, we want to use some grid solutions, and yeah, to try to involve some grid solutions for and to try somehow embed orchestration in this mechanism. Actually, I guess during the first day where there was a more elaborate discussion of this Croupier plugin done by Javier Nieto from Atos. And yeah, probably he discussed it a little bit more details.
Okay. Let me ask you a naive question, please, then then you're free to go. You mentioned that you guys basically worked also a little bit on messages and Twitters about COVID. Is that correct?
Yeah, we start that activity just started a couple of months ago, maybe
For obvious reasons.
Yeah, yeah, like anyone, everyone almost started to work in this direction. And
yeah,
we're working
everyone.
in global challenges. That's our one of the activities which we could not leave somehow behind our scope.
Definitely. Okay. That was a very interesting talk. Thank you so much.